Okay, we'll go ahead and get started. So thank you for those that just joined us. We will be taking questions at the end of the program. Please use the Q&A for that. And now I'd like to introduce Dorla Cantu, our committee chair for the educational programming for UCSF Retirees Association. And Dorla, if you could go ahead and start your video.
Okay. Hi, everyone. Thank you for joining us. Some of you may recall that when we started our speaker series at UCSF several years ago, our first presenter was from the UCSF Memory and Aging Center. That was Dr. Sergio Lanata, who unfortunately wasn't able to join us last week. However, we hope to reschedule him at a future date. Meantime, continuing with this series of workshops with memory and aging, I'm pleased to introduce today's speaker, Dr. Stefanie Piña Escudero. Dr. Piña Escudero is a geriatrician working to understand and reduce the impact of social vulnerability on older adults with cognitive impairment. She received her medical school training from the National University of Mexico, where she completed her training in geriatrics. She received her internal medicine training from La Salle University. She is an Atlantic Fellow at the Global Brain Health Institute and a PhD candidate in the UCSF Pharmaceutical Sciences and Pharmacogenomics graduate program, where her focus is on genetics and aging. Welcome, Doctor.
Thank you for the introduction, Dorla, and I am very happy to start this program and this collaboration again with UCSF. I think that brain health is something that everybody should always take into account. So I am going to share my screen. Oh, no. I hope you're able to see it okay. So the first class the first presentation that we're going to have this module is on air pollution. This is a series that we build thinking about transmitting how the things that are around us can affect our brain health, and we called this series NeuroNose, thinking about how all of these pollutants can actually connect to our brain health. And of course, brain pollution or air pollution. Of course, air pollution is a very important part that connects the nose to the brain, because all human beings need to breathe. And here I wanted to just make a little bit of a short explanation of how this process happens. How does air get into our lungs? This is a person that is cut in half. Let's say that it's like a slice, a frontal slice, but with the face looking towards one side. So imagine that you're cutting just a person with a face to the side, but this is a frontal slide. So these are the shoulders of the person. So this is the nose, and the air goes in through the nose all the way down to the lungs by the throat. And what I want you guys to see is that the lungs are like big bags full of air, but they are not just one big compartment. Actually, the structure of the respiratory system is formed by very, very, very small bags tied together. And they are as small, maybe they are a little bit bigger than dust, and we're gonna look into that in a little bit. Then as a hair maybe, and there are thousands and thousands and thousands of them that come together to form the lungs. So when you breathe in and your lung expands, actually all of these little tiny bags are getting filled with air. And when you exhale, all these tiny little bags become a little bit more flat. Importantly, that these bags never totally collapse. They stay a little bit open so that they can do this movement when you breathe. This very tiny little bag structure has a purpose, and it is because in order for you to get oxygen to the rest of the body, you need to get it from air. And if we had just this huge bag, then blood vessels would only go around the bag and we will lose space. All the air that would be in the middle wouldn't get into our blood vessels. So the body is smart and created this very efficient system of very small bags where the capillaries and the blood vessels are behind these very tiny membranes. You can see them here in the picture. These are the blood vessels, and they are in close contact with the air. So the red arrows exemplify the air coming in, and then your blood vessel is right here. So this is like a zoom into the blood vessel, and you can see that oxygen comes in. These are the blood cells. If you remember from probably your high school classes, the blood that comes to the lung is the blood that has already collected all the carbon dioxide and the things that we don't want from the rest of the body. So when it comes in, the red blood cells that are actually these ones that are in different colors here inside the blood vessel get oxygenated. So they come like without oxygen. They let the carbon dioxide out and they exchange it for the oxygen. So the air that comes in brings in the oxygen, and these cells are red and vibrant again, and they are ready to take oxygen to the rest of your body. And then when they come back, they come full of of carbon dioxide and other things that are, let's say, body waste, and they get exhaled, they get out. So when you inhale, the air comes in, turns your blood cells into cells full of oxygen that can go to the rest of your body. When you exhale, you let the carbon dioxide out, and then that's like the waste product of your body with the respiration. Now, why is this important, or what does this have to do with the brain? Well, if you have a lung disease, a respiratory disease, if there is a toxin, a toxic substance, any type of thing that impedes or alters this normal process, it is going to directly affect your brain. How does that happen? Another tiny reminder. So this is our brain, and actually I like to represent it with the fingers of the hand. So let's imagine that you make a fist and you leave your thumb inside of the fist. So all of the parts that are outside of like the fist that you just made are the surface of the brain. So these superficial parts that are exemplified here are the cortex of the brain, and areas that you use to see, to hear, to feel are on the surface of the brain. But the memory is exactly where your thumb would be, in the middle of the brain. So it lives in a structure called the hippocampus. That is right here. So this is like the brain sliced so that you can see what's inside of the brain. Of course, it is inside because it is a very important area and it is protected from all the trauma that can happen to the external parts of the cortex. So it is called a hippocampus, and it is this structure because it resembles a hippocampus. It's like seahorse. And this is where the memory lives. But the hippocampus is one of the most sensible structures that our brain has to the lack of oxygen. So if something happens to our lung, it would directly impact our memory. There are other diseases that don't have to do with air pollution that have this impact. So let's dive into the topic that we're going to talk about today. And the first thing that I want you to know are some concepts. So we're going to start with air quality. What is air quality? Well, that definition is that the concentration of pollutants that a person reaches more or less far from the emission source when transported and diffused through the atmosphere. So what does that mean? That pollution is not exactly what comes out of a factory chimney, but what remains in the air after these pollutants have been dispersed in the atmosphere. So what you receive if you are walking by a factory or if you are in near proximity to a factory, that would be what where the air quality is measured, not directly right here. Now, what are the factors associated with air quality? There are two important factors. The first one are the human factors, and the second factor are the environmental factors. What are the human factors? Things that have to do with factories, thermoelectric plants, internal combustion engine vehicles, such as cars, buses, etc. The fuels that those engine vehicles use, such as diesel, gas, coal, or biomass, meaning gasoline. Also heating stoves, and a very important source of that determines air quality is tobacco. Now, there are also some natural sources that determine the air quality. For example, if there are strong winds and they transport suspended particles, if there are fires, if there are volcanic eruptions. I remember that last year there was a volcanic eruption that happened in a volcano that is actually under the sea, but the emissions made it all the way to the island. So these are things that we cannot control that happen every single day, and we need to work around them. But these are the factors that we can control. Now, taking all of these things into consideration, the World Health Organization developed an index that's called the Air Quality Index. And this is a figure that is provided to reflect how much pollutants are present in the air. So it is color coded, and we're going to see it more in depth, but in a broad way, if colors are closer to green, that is good. That means that it does not affect health. And if it is closer to red, it is bad, and it actually affects health. So when you go into some websites that are available for you to see the quality of air, I recommend this one because this one is or displays the quality of air of San Francisco in real time. You're going to find this scale, like air quality index values. What do they mean? Sometimes we see exactly a banner like this. So it just gives us like, okay, USAQI, what is that? What is this number? What does that mean? Okay, so there is a range. Remember that I told you that if the color was closer to green, then it was safe, and if it was closer to red, then it was dangerous. So they divided the amounts of pollutants into different cut points depending on how much pollutants were present in the air. And from 0 to 50, then it's good, and the banner would be green. From 51 to 100, as it was yesterday, the air pollution would display a yellow banner like this. And when it is good or moderate, meaning the banner is green or yellow, we can be relatively calm. But then when the banner starts being orange, then the air is starting being unhealthy for sensitive groups. And who are the sensitive groups? Older adults are are a part of the sensitive groups. Why? Simply because our bodies don't have the same ability to compensate for the lack of oxygen as young bodies have. Other groups that are among these sensitive groups are people with respiratory diseases, people with asthma, people with COPD, people who use oxygen for any reason. After COVID, a lot of people had lung damage from COVID, and they became a part of the sensitive groups, and they use oxygen for health reasons. They became a part of the sensitive group. If it is red, if you see a red banner, that's definitely unhealthy. Purple is very unhealthy, and maroon, it is hazardous. And the numbers are here. So 0 to 50, 51 to 100, 100 to 150. So basically, there are 50. The increments are in 50s. So I did a search for how does San Francisco look today. It looks mostly green, although there are some areas that are yellow. There is actually an orange area behind this green dots that we're going to look a little bit into more depth in a couple of slides. But I want you to see that although San Francisco looks fine, there are other places in the US that don't look exactly the same. So this is the World Quality Air ranking. And you can see that the most polluted city is Dubai, and this is due to sandstorms. They have a lot of sandstorms, a lot of factories that don't help their air quality. But you can see that there are some other cities in the US that are actually not very far away from it and that don't have the yellow or the green banners. For example, Detroit, Chicago, Minneapolis, they are all in like the reddish, purplish colors. So you can see that the quality of their air today is from unhealthy to very unhealthy. And people are just continuing to live their lives as normal there. So you can think about that every time they breathe, they are literally harming themselves. And why does this happen? Well, yes, we said that the World Health Organization put these numbers into place, but realistically speaking, 99% of the world's population lives in places where these guidelines are not respected. And it is important, and we're going to look into each of these components of air pollution: particulate matter, ozone, nitrogen dioxide, and sulfur dioxide, because they are produced in different ways and they can damage you in very similar ways. So the first one that we're going to look into is particulate matter. So what is that? What component of air pollution is that? Well, the first thing that you have to know is that particulate matter is a part of pollution that affects more people than any other pollutant. And these are like the solid parts that you can find in air pollution. They can be formed by a bunch of substances. They can be sulfates, nitrates, ammonia, mineral powders, powder per se, like the one that you use to cook, the one that you put on your feet. All those powders become air pollution at some moment. The important thing is how big they are, because on that, it will depend whether they get to your lungs, they get to your blood, or they get where. Let me show you an example here. So this is human hair. This is a strand of hair. If you feel your own, or if there is somebody that is at your side, you can feel their hair. It's super, super, super thin. And this is fine beach sand. You can see that even fine beach sand is a little bit bigger than what our human hair is. Beach sand is 90 microns in diameter, and the human hair is around 50 to 70. When we start considering a pollutant important for disease is when it is below 10 microns. And you can see that 10 microns is a super, super, super fine particle. A series of them can fit into the hair. But the most dangerous ones are the ones that are below 2.5 microns. You can see that these red balls fit into this blue ball. So you can imagine how tiny are they. Why are these important? These blue balls, the balls that represent 10 microns or less, are the ones that are going to stick into the little sacs in your lungs that I showed you before. These have the potential to cause lung disease, asthma, COPD. A lot of people are allergic to this dust, pollen, mold. For sure that if you had an allergy test, they would tell you that they are the cause of your respiratory symptoms. But then there are other particles that are super, super fine. And as I told you, these mini sacs that are in the lung are in very close contact with your blood vessels. So these compounds will go all the way into your blood and they will be distributed all through your body. And these are mainly things that are from combustion, such as gasoline, diesels, some metals, some toxic substances that are released into the atmosphere. We're going to see a little bit more about them. But this is how small they are, and this is why they are important, because they are so small that they can stick to your lung or they can go all the way into your bloodstream. Importantly, the ones that the particles that are very, very small and go into your bloodstream can make it, or can potentially make it all the way into your brain, because some of them are so small that they even cross the blood-brain barrier. That is the thinnest structure that our body has that a particle can cross. Just as an example, I wanted to show you how the lungs of these people look like. So these are lungs from people who are deceased. So in a very respectful way, I want to show you how healthy lungs look like. So if you can see, these healthy lungs are from a person that came from a place that was not very polluted. The lungs look pink. And these lungs come from a heavy smoker. So you can see that the particles that are in the cigarette actually accumulated in the lung of this person throughout this person's life. And when you inflate the lungs, I want you to see how they inflate differently as well. So when you introduce air into the pink lungs, the healthy lungs, you can see that they inflate evenly. So this person is able to breathe fine. But when you do the same in the black lungs, you can see that there are places in the lung that are not inflating anymore. And this is because when tobacco smoke sticks to your lung, causes an inflammatory reaction that destroys the sacs that are in your lungs. And those regions won't inflate anymore, meaning that there is no oxygen interchange in the regions that are not inflating anymore. Therefore, if your brain is not receiving oxygen, your memory can become impaired. So these particles are generally reported in particles per million. And those are the particles per million that are found in a cubic meter of air. So although this is very abstract, I think it is important just to pay attention to the numbers. In San Francisco, the daily average is, let's say, 15, and the coarse particulate matter, that are like the largest particles, that are 10 microns, is 45. Those are usually levels that are within the normal range, as we already said. Below 50, everything is okay. But there is this particular area here in San Francisco that always remains on the high, not healthy levels. So it doesn't really matter what time of the year. I have looked it up a bunch of times now, and it always remains over 100. So this place is the Alemany Boulevard, and when I Googled mapped it, you can see that it is very, very close to where all these roads actually cross. And if you actually look closer to this is worrisome, not because the roads cross, not because the air pollution is high here, but because there is a nursery and a park right here. So there are literally babies that are inhaling the worst quality of air that San Francisco has to offer. So if we have like a bad start in life, it is very hard to compensate for that later in life. There are also a lot of people that are living here. This is a residential area. This is not a factory area. But that takes me to other components of air pollution that are not necessarily these particles that attach to your lungs or that go all the way into your bloodstream, but the particles that you breathe, the gases. There are two very important gases, ozone and nitrogen oxide. And these are important, ozone and nitrogen dioxide, because they come from very common sources of pollution. Aerosols, motor vehicles, products that we use in our kitchens, in our house every single day, everything that we use in spray, even though it says that it contains fewer of these substances, they do contain an amount that is enough that if it's used by a lot of people, it starts accumulating in the atmosphere. And then the nitrogen dioxide comes from factories. It comes from buses, from products that get combusted. So these two, the ozone and the oxygen nitrate, the nitrogen dioxide, make a reaction with the sun. So when the sun gets in touch with these gases that are produced at home or that are produced in industries or factories, the sun oxidizes them, and then they create this coat over the surface of the ground. What does that mean? That this coat is like a thick coat that impedes the heat that is produced in the ground to dissipate. Now, this heat comes from everything. If I use a car, the car produces heat. If I run, I produce heat. All the things that produce heat in the ground are not able to dissipate, and that leads to global warming. And this increases the wildfires, this increases just the temperature in general, but increases the temperature in the water and fish die. And it is not good for anything in nature. But what is the health effect of that, besides fish dying and plants dying? Well, it creates oxidative stress. What does that mean? And I put a very simple example here. I think that everybody has seen a tomato oxidizing, right? If I leave a tomato outside of the fridge, this process starts happening. This is a normal cell anywhere in your body, but especially, for example, you can see it in skin cells because they are very exposed to pollution. So you see the normal cell here. If it gets in contact with these pollutants in the atmosphere, the same thing that happens to the tomato happens to your cells, and they start oxidizing. So you can notice that people that smoke, that people who have lived in polluted areas have more wrinkles than people who didn't smoke and people who didn't live in polluted areas. And this is a very clear way of seeing how our body gets oxidized by these substances. Now, there have been many, many experiments, not yet proved in humans, but in rats, that these pollutants also cause inflammation in the brain. And why is it important? If there are effects of ozone and nitrogen dioxide oxidizing these cells in the brain, then our ability to repair a neuron diminishes. This is very, very, very important because the brain, when you are born with a lot of neurons, and they die as you grow up and then as you age. And for those neurons, if they get damaged to get repaired, it's a big deal. They take a very, 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 very long time. Some of the times you would die before they get repaired. But if there is inflammation, they repair themselves in an even slower way. So what happens when there is no neuronal repair? You are more prone to accumulating substances in these intents or attempts of trying to repair your cells, accumulating proteins there that have been proven to cause Alzheimer's disease, such as amyloid beta. So ozone in San Francisco is usually in very good limits, let's say. There are other places in the US that are not in such good limits. So you might take a look in case you lived most of your life in one of these places, especially in Ohio or Illinois, that are usually the places that have more ozone in their atmospheres, in the purple levels. But I wanted to call your attention to a phenomenon that happens in San Francisco, and we usually don't pay attention to it. As I said, most of the year, the levels remain green. But then, if there are fireworks, this is taken from the New Year's fireworks, then the ozone level rises. And here in San Francisco, people have a lot of excuses to actually use fireworks. There are a lot of celebrations, baseball celebrations, religious celebrations, independence celebrations. So 4th of July is around the corner, just keep this in mind, that it might not be healthy to be exercising or breathing outside right after the fireworks are cracked. The same thing happens with nitrogen dioxide. San Francisco is usually in very low levels, but then when there are fireworks, these levels really rise. And there is a pollutant that I didn't find it measured anywhere, or at least it's not reported in a consistent way. That is sulfur dioxide. This sulfur dioxide is produced in factories, and these factories and these things are mainly located in Bayview, Hunters Point, and in the East Bay. And these factories actually create what we call a sulfur belt from the burning of these industrial zones. And this sulfur belt actually crosses the city of San Francisco. And what we know is that cardiovascular mortality and lung diseases get worse the days that sulfur dioxide are high. Keep the sulfur dioxide in mind, because I'm going to tell you a story a little bit in a couple of slides that goes with how pollution changes over the year in San Francisco. So air pollution in the winter is dangerous because certain reasons. Air pollution in the summer is dangerous because different reasons. So the first phenomenon that I wanted to talk about that happens in the atmosphere is thermal inversion. I am sure that probably a lot of you have heard about it, because as we have said, global warming is a thing. So what usually needs to happen is, this is a city. Let's imagine that this is San Francisco. So San Francisco produces a lot of heat from the industry, from cars, from people, from you cooking, anything that happens in the city during the day. This warm air is ideally dispersing up to the atmosphere, and all of the pollution that was produced in the city during the day should also be dispersed into the atmosphere. When it is cold in the winter, this doesn't always happen this way. So we said that when there is a lot of pollution, this layer of smog is created, right? When there is oxidation of pollutants, this layer of smoke gets created here. So yes, you're all going to cool down overnight. There are no cars, there are no people running out in the street. Usually people are not cooking. So it becomes a little bit cooler overnight. But then when it gets cold and the cold gets trapped in this smog layer, the heat that is produced during the day cannot escape. So it gets warm down here. There is cool air trapped over the layer of smoke. Then there is warm air that was being released from the previous moment, or the previous days or months. And then there is cold air. So cool air cannot go through this layer of warm air because it is heavier. And we need to wait until this warm air gets dispersed so that all the heat that is produced down here gets dispersed. So all the smog gets trapped down here. It cannot be dispersed normally. It gets trapped close to the city, close to the ground, and we are breathing it. There is a very clear example that happened not in San Francisco, but yes, in the United States in 1948, and that is how we actually learned that this happened. It happened in Pennsylvania, and it has been the worst air pollution disaster in the history of the US. So what happened here is that a lot of sulfur dioxide, remember that I told you to please keep it in your heads, was produced by a lot of different factories. There were mercury factories in this area. So there were a lot of pollutants being released, and this inversion phenomenon happened during Halloween, actually, when temperatures started cooling. So there was cold air trapping all these pollutants in the city because they could not be dispersed through the warm air that got trapped here. There was a yellow cloud in the city, and that same day, 19 people died, and a lot more would have died if the city wouldn't have been evacuated. So this is how dangerous it is. And in the winter, we need to keep this into account, that there are days, like I mentioned, where there are fireworks, especially New Year, where these phenomena in the environment are happening, and then all the pollution gets trapped in San Francisco. Another example, even though we know about this happened in the 40s, but it's 2023, and these things still happen, these accidents still happen. There was a derailed train in Ohio with toxic materials, and this happened during the winter. So this temperature inversion also prevented pollutants from being dispersed into the atmosphere. And this like black mushroom that you see here stretched horizontally, and people were breathing it for a while instead of going up. So in the winter, it is very important not to release any sources of pollution from the ground because they get trapped and we inhale them, and that affects our lung health, our cardiovascular health, and very importantly, our brain health. Now it's the summer. What happens in the summer? We have fires. Now, fires release all these particles that we were talking about in the beginning. When there is a fire, there are a lot of things that are burning. I know that wildfires are usually associated with trees getting burned down, but actually there are many, many things that burn down when these wildfires occur. If they reach, for example, houses or trucks or roads, there is plastic melting, there's steel melting, there is anything that's on the way of this fire melting. So the smoke that is produced by wildfires is highly, highly, highly toxic. And these smoke particulates from wildfires actually cause from 4,000 to 9,000 premature deaths and cost from 36 to 82 billion per year in the United States. So it is very important to protect ourselves against this. What can we do? What can we do if the air is highly polluted? Well, the first thing is not to breathe more than necessary. So it is not recommended to do exercise outdoors if there is a fire, if there have been fireworks or other sources of pollution in the air the day before or the day of, and definitely not if you can actually see that the air in front of you is polluted. I am going to give you an example because sometimes when this is produced in a very gradual way, we don't really realize it. So I grew up in Mexico City. For those of you who have been in Mexico City, you might have noticed, or maybe not, that Mexico City is a valley and it is surrounded by mountains, huge mountains. And most of the year, the city is so polluted that we cannot see the mountains. Mountains are like super big and super huge, but it is so common, it becomes such a part of your life that you kind of forget or block or lose importance of how polluted the city must be if you cannot see something as big as a mountain. When there were wildfires here, I remember this very clearly, and I think it's when everything struck me. It was 2018, the year that I got to the US, and there were very big wildfires, and I could not see the Giants Stadium. I lived very close by, and I worked very close by, so I couldn't see it. I mean, I knew it was there, but I could not see it. It was super polluted. So if you see that the atmosphere is like that, please don't walk, please don't run, please don't exercise outdoors, because you are going to be stimulating those pollutants into your lungs. The other thing, and I think this is like one of the positive things that COVID gave us, is that it taught us how to use face masks. It is very important that when there is air pollution that we use N95 face masks, because these are the only masks that are designed to actually impede these big polluted particles from crossing. The normal face masks, the cloth face masks are going to help, but to a certain extent, not as much as these face masks are going to help. And the other thing is to eat foods that are rich in antioxidants. We already said that when it is a lot of pollution in the atmosphere, your cells oxidize. So protecting them with citrics, such as lemons, limes, oranges, tomatoes, actually help. So increase the consumption of these vegetables when there is a lot of pollution in the atmosphere. And what are things that we can do on a daily basis to actually reduce pollution? Well, when there isn't, contrary to what I just said, when the air is fine, the quality of air is fine. If you can walk, walk. Avoiding taking your car or driving your car, avoiding taking public transportation actually helps. Recycle, this is super important. A lot of the pollution that is in the city comes from trash. Prevent fires. I know that in the summer weather gets nicer and people want to go out and camp and things. If you're not camping yourself, but your family is, there are a lot of recommendations to prevent wildfires. And the other one is plant and care for trees and just plants in general. I know that people in every group, there are people who like gardening, so get in touch with them, plant a tree, save the world. But most important than saving the world, making a better quality of air will improve your own health. These are other things that usually we do at home that we don't realize that make our environments being polluted. So keeping our living space clean is very important. There can be a lot of dust, there can be dust mites, there can be bacteria, there can be pet hair inside our homes. And that is as terrible as the air pollution from factories, from all the from fires that I have just described. So if you don't keep your space clean, you are going to be breathing in all of these pollutants. Another important area to keep an eye on are kitchens, especially when we cook. So when we cook, we are burning things, like we are changing the chemical structure of things. So we need to keep a window open, a door open, let the air come in and exchange that air that gets polluted from cooking our food in and let clean air in the house. Of course, if you start a fire in your fireplace, that might also create pollution, so please have a chimney. And it is also important to say that the bathroom, if not kept clean, all the gas that comes from the toilet, is also pollution. It is also detrimental to your health. Important things that we use include some products that we use for cleaning. So when we use products for cleaning, it is also important to open the doors, open the windows, and not let those products accumulate. There was a group where I taught where a lot of people liked the smell of bleach. It's like, if my house doesn't smell like bleach, it's not clean. If you can smell the bleach, is that you're putting too much and the environment is polluted. You need to, whenever you clean with bleach or with any other substance, you need to open windows, you need to open doors, otherwise it will be accumulating in there. Another important point is to keep the pets clean. This is usually not very taken into account. But if your pet is dirty, it is also accumulating dust, it is also accumulating dirt, and the fur that gets on the pillows, on the clothes, and everything that you breathe is also dirty and you're breathing it. Do not accumulate garbage. There are also a lot of people who like to accumulate a lot of garbage in the kitchen because, okay, trash day is just once a week. So I am going to accumulate the trash in the kitchen for the whole week. And actually, food is getting rotten in your kitchen and you are breathing that. So my recommendation is to have smaller waste baskets and take it out of your house or your living space in a more regular way. And here is just a close-up of dust mites. So maybe you see that your house is dusty, but dust is not the only thing that gets into your lungs. There are also some parasites like dust mites that can get into your lungs, that get attached to your skin, and that can create disease. It is important that when you clean with a wet piece of cloth. This will prevent dust getting everywhere, and this, when you clean and dust gets everywhere, it's easier for you to breathe it. So if you can keep it on a wet piece of cloth instead of in your lungs, that will keep you healthier. Like I said, ventilate. I know that especially August is a very cold month. The winters are very cold. We just need 10 minutes of air into our homes. If we breathe, as I said at the beginning, we are producing carbon dioxide ourselves. If we never ventilate the space that we live in, then that carbon dioxide also accumulates, especially if we don't have plants at home. So we need air exchange inside of our houses. Otherwise, we become sleepy, we become tired all the time. And sometimes people don't know why that is happening. And it is because they haven't ventilated the space that they are in a very long time. Other things that we can do to keep our homes without pollution is to keep them dry. And we keep them dry by using devices that prevent many thermal inversions from happening. So remember what I told you that happens in the air, that there is cold air. Imagine that that is your kitchen floor. It is cold. Then in the middle, you start cooking on the stove that creates warm air. And then your ceiling is again cold. So there are mini thermal inversions that go on in the kitchen, and everything that you cook stays within the range that you are breathing. So if you have kitchen extractors that actually absorb all of those things that you're cooking, like the smoke, I'm going to call it, from things that you're cooking, you are going to break that mini thermal inversion that is going on in your kitchen. Also in the bathroom, use the bathroom fans, remove all the surfaces that have mold. This is also important because if there is mold at home, the mold also generates toxic gas that you might be breathing. Please don't paint over it. You need to remove all the mold from the surface for it to prevent it from producing toxic gases. Like we mentioned, burnt food is as if you were burning any other thing outside, like fuels and everything, because this is organic matter. Typically what we eat is organic, right? Otherwise we would not be able to eat it. So this is what happens when you burn your toast. It's a mini micro scale of what happens when you burn fuel. So it is very important to keep into account that if you are burning food, you need to ventilate your space. If you smoke, I will always, always, always recommend you not to smoke indoors. And definitely not use spray products inside the house. Now, heating, air conditioner, heaters need to be very closely watched, especially the ducts, because people here in San Francisco, buildings are very old. And since we don't use neither the air conditioner nor the nor the heating as often, we don't really clean it also that often. But there might be all of this dust inside of those systems. And when you turn them on, all that you're going to do is to breathe them. So that's why when people turn on their heaters or they turn on their air conditioners, they become, or their allergies become more marked. Okay, so this is just a reminder of the things that we had said before. And this is an important reminder when it goes to reducing indoor pollution because of filters. Filters got super popular with COVID, but this is a reminder of how things look like. So this is your hair. This is fine beach sand. And the things that you need to look for in a filter are that they actually filter pollen, that would be here, around 15 microns. Better filters will say that they filter dust. So those dust is around here, 5 to 10 microns. And even better filters will say that they filter smoke, especially in wildfire season. You need to see that if you're going to have an air filter, it says that it filters the smoke because those are the tiniest particles that a filter can filter. They are around 0.4 microns. So they are super, 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 super tiny. It is very important to say that this is as far as filters go. So they don't filter things as COVID or other viruses or bacteria. When you get a filter for your house, it is important to see what that filter was designed for. It would usually give you two values. First, the card value, that is how much of the surface of your room gets actually filtered. So let's say that if you have an area of 100 square feet and the card value of your filter is 65, only 65 of the air that is in the room is going to get filtered, and so on. So when you buy a filter, it is important to buy the adequate filter for the size of your room or the space that you are in. And I think that's it. I think we have space for questions. Remember that protecting your lungs, protecting the air is also protecting your brain.
Thank you, Dr. Piña Escudero. That was actually very informative and really interesting, especially about that that specific area in San Francisco that, you know, is kind of highly polluted. How do they measure the air in San Francisco?
So there are sensors that are placed all around the city. So the sensors are fixed and they monitor the air pollution by the hour, actually. So if you go into one of these websites, you can see they typically report like the morning, the afternoon, and then the evening. They usually do like 3 reports per day, and you can see how the air quality is fluctuating because those sensors are fixed around the city.
Interesting. And just a reminder, I mean, we are taking questions. You could either put them in the chat or the Q&A. I have a question here. It says, thank you for a very interesting lecture. Can you say anything about methane pollution from agriculture and its impact on health?
Sure. So methane pollution. Okay, there are two important things here, like what it does for the environment in general, because it also creates this thermal inversion, right? So when there is a lot of methane pollution gets trapped at the level where we can breathe it. That is one thing that is important. But the other thing that is important is that when it is a lot, especially in the places where there is agricultural work and industry, it can be detrimental for the health of the lungs immediately. People that inhale a lot of methane can have allergies, can have asthma, even there are some people who develop COPD.
Here's another question here. This one is kind of interesting because I have some air purifiers at home and I'm always curious if I have them placed right. But does it matter the height of where the air purifier is placed in the room?
It matters if it's the kitchen. If it is your bedroom, if it is the living room, it doesn't really matter because air flows in a constant way. But if it is in the kitchen where we are creating these mini thermal inversions, you need both an air purifier that is located at the stove level and then a filter that absorbs the things that you're cooking.
Yeah. And then what is the difference between IQ-AIR and purple air? IQ air, I guess is what they're saying.
I believe that they are just two different air monitor sensors. So there is not really a big difference. I think that the only difference is like the way that they monitor and what they measure. Like I mentioned, IQ air measures basically this three components that are particulate matter, nitrogen dioxide, and ozone in the atmosphere. And they have sensors located in different spaces. And purple air monitors basically carbon dioxide and nitrogen dioxide. And they are like little monitors that you can put anywhere. So it just depends on the system that they use, but there are no significant differences. You can use whatever you want.
And then what would you recommend would be the best way to effectively remove mold in the bathroom?
Sadly, the most effective way to remove the mold in the bathroom is actually remove the part of the wall that has mold. So a professional needs to come, scrape off that part of the mold, put a special material that prevents moist from accumulating in that part of the wall, and then repainting the wall or putting any coating that you have on the wall. But that is like really the only effective way to get rid of mold. You can, if it is a very, 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 very thin layer of mold and it is on top of a material that is not for example, like wallpaper, if it is more like marble or like these rock materials, then you can scrub it off. But it really needs to be a very, very, very thin layer. But if it is on a wall, you need to remove that part of the wall.
And for cleaning on, let's say a tile or, grout, I mean, because bleach is like what people think is the best way to remove, mold and mildew. What would you suggest then? I mean, to remove just like daily or, weekly cleaning?
So, I mean, more than removing, I would suggest that you actually monitor how much moist is in your house. There are like a lot of things that you can use that absorb moisture in the house to prevent mold from accumulating. And then just clean as you usually clean your house. I mean, it's not wrong that you can use bleach, but you need to use it in the appropriate proportion. So if you use a gallon of water and 2 tablespoons of bleach, and you use like the proper protection, you protect your hands, you use a face mask while you're cleaning, then you're not going to have any problems. The problem is that people put a ton of bleach and then they are just cleaning it with their hands very close to where they are smelling it, and they are not ventilating their houses. So It is just the way that we use the products what might affect our health, not so much the product itself.
Yeah. And actually somebody put in a remark in regards to the Purple Air. It says Purple Air is a company that sells sensors for both indoor and outdoor measurements. The measurement can be uploaded on the internet and results are available on maps on their website. Let's see. Does air pollution have effects on water?
Oh, you're going to have to wait for the next talk for that one. That is exactly what they're going to talk about.
Good. I hope everybody heard that. We'll be back next week for the next program. Let's see. Are there regional areas and state will air reporting, or I guess regional and state areas reporting? What are the websites if you have them? I see that they're asking about state and regional area report maps. I think you provided one earlier. It was that
Yes, let me see.
iqair.com.
I don't know if I can drop it here. No. Yes, aqair.com. And you can take a look there. It provides information by state and by regions.
Okay. And which of the pollutants you discussed are more dangerous specifically for brain memory health? And also, if there is damage due to pollutants, I mean, is there a way to reverse that? Or once it, like the hypothalamus, I mean, once it happens, I mean, is your memory permanently lost, or what happens?
Yeah, okay. The most important effect specifically over memory, although it hasn't, okay, here's where we are at research, right? We know, or what we have seen is that in the brains of people who have died, that live in very polluted cities, and these are basically data from two very polluted cities that are Sao Paulo in Brazil and Mexico City. So people that we have taken their brains after they die, and we perform an examination on their brains, we find that particulate matters, especially from gasoline combustion, are the ones that affect the brain the most, or these memory areas the most. What we haven't been able to establish, and this is merely because of logistic problem, is the link to the lung. So unfortunately, autopsy programs are focused on people donating their brains or their lungs or specific parts of their bodies to science. So we have seen that people who live in the same areas have those substances in their lungs, but the people who donate the lungs and who donate the brains are not necessarily the same person. So we haven't been really able to establish that link happens in people, but what we know is that we see the same substance that is coming from the combustion of gasoline accumulates in the lung and accumulates in the brain. And people who have those substances from combustion of gasoline in the memory parts of the brain, like the hippocampus, actually have memory problems. There are some studies that are being conducted right now that in these highly polluted cities, even kids at school perform worse, cognitively speaking, even if they are healthy children, if they don't have any lung diseases or anything, perform worse than people who don't live in such polluted areas. So all of these things suggest us that the products from gasoline combustion are the worst for memory. Now, once the brain gets damaged, it gets damaged. There is no way back. Even though there is some plasticity, like I said, there are certain areas of the brain that can grow to take over. When there is a lot of damage by pollution, those repair mechanisms get slowed down. So maybe you're never going to be able to compensate for that loss of neurons.
Let's see. And then in regards to lung tissue, does that regenerate? Right? Like if somebody stops smoking, does the lung tissue come back to normal?
Well, it doesn't quite come back to normal, but let's say that, for example, the risk of cancer that you had decreases after you stop smoking for 20 years. It is the same as if you would have never smoked. Let's say that your risk is the same of having cancer as the general population. People who don't smoke also have like a certain risk of getting lung cancer. If you stop smoking 20 years, your risk decreases all the way to the normal population's risk. That said, if you stop smoking, you will see a benefit in the rest of your functions, in the amount of oxygen that your body receives, in your cardiovascular health day one.
Hmm. And once pollution particles go into the lung capillaries, are they trapped there, or does the lung expel most of them?
It depends on how big they are. So, and how healthy your lungs are. So we saw this video of the lungs. So if they are very, very small particles, they can go all the way to your blood, and they can actually go all the way to all the different parts of your body, come back, and you can exhale them. So there is a proportion of particles that are going to end up outside of your body. But there is a big proportion of particles that can get captured into your lungs, and they are going to stay there forever. And there is a small proportion of particles that is going to be stuck anywhere else in your body. That's not necessarily your lungs.
And then how are home gardens affected by air pollution, or will this be talked about next week also?
I would need more information. What do you mean by how are home gardens affected?
Yeah, I'm not really clear by that either.
Yeah.
It seems like a home garden would probably kind of help. I mean, because it would help kind of filter the air, maybe. I don't know. Are there studies that have linked pollution to dementia or Alzheimer's in particular?
Just what I said. We have seen that Alzheimer's disease has been affected, or is more in the people who have more of these products of gasoline combustion in their brains.
Okay. And this is our last question. Is there research on the fate of the microplastic particles we are hearing about in the air from, I guess, from the cigarette butts? You see the commercials on TV all the time.
Yeah, well, it is starting to be. I am not aware that there are any definite conclusions right now, but I know that there is a lot of research that is being conducted. There is a lot of research that is being conducted, mostly in relation, not so much to brain health yet, but to cancer. So stay tuned. I think that those are results that are going to be out soon. And I know that there are people who are starting the research on the brain. So that will probably take a little longer, but we will get there. I would just say, going back to house gardens, that I just remember an experiment that was being conducted in a garden in also the University of Sao Paulo in Brazil. They have a very big garden in the university, and they measure the pollutants that get stuck to the leaves of the garden, of the vegetables, of the plants that grow there. So yes, pollution from air gets stuck to the leaves, but most of the pollutants were able to be washed off. So there were very few pollutants that actually got stuck to the leaves in an unremovable way. So that's important. That's why it is important to wash your vegetables before you eat them.
Very good. Well, thank you so much, Dr. Piña Escudero. We really appreciate your time, and that was actually very informative. I hope people at home, take this information and help, with your indoor pollution and just pollution in general. We will be off next week. I hope everybody enjoys their 4th of July. Please do not breathe too much outside after the fireworks. But we will be back on July 12th with water pollution and brain health with Dr. Charles Winden. And we hope to see you then. Thanks, everyone. Bye.
Thank you.
Bye-bye.